Good evening, my geometrically minded minions and minionettes. Glad to hopefully see you back in class this next day. Well, we need to talk about right triangle congruence theorem. So up to this point, we've had several theorems that we've added into play. We've looked at for any triangle, we've said, hey, we can prove them congruent by angle, angle, side. And we said second, we can do this by side, side, side. And then we can prove them congruent by side, angle, side. And then we turn around and we brought in angle, side, angle. But now we're going to look at some that are specific to right triangles. Okay, so specific to right triangles. Now, some things we've got to bring into and kind of revamp our memory about is in right triangles, we've got a couple of specific things. Now, one, we've got some very particular names for the sides. In a right triangle, we have two legs. We have these two short sides. The two shorter sides are called legs. Now, which one you call leg one and which one you call leg two, that's just semantics, completely up to you. But the longest side, the one that is right across from that right angle, it is called the hypotenuse, okay? So terminology that we've got to be aware of, the hypotenuse. Now, the other thing that factors in when we start dealing with right triangles, remember we've got that wonderful Pythagorean theorem. So a squared plus b squared equals c squared, and that comes into play when we're dealing with right triangles. So right triangle congruence theorems, just like right triangles have this special theorem called the Pythagorean theorem, well, they've got some special congruence theorems about them. Now, does that mean that you can't use angle, angle, side, or side, 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 or side, angle, side, angle with them? No, it doesn't. Those are always going to be used, and you can use those anytime. We just have some special ones that exist, or special name ones for right triangles. However, if you forget the special right triangle congruence theorems, can you always go back and prove them congruent using these four that we've already covered? Absolutely. Okay, so the first one we're going to look at is called hypotenuse angle. So when we look at a right triangle, and these only work when we have a right triangle. So if we have a triangle that's a right triangle, hypotenuse angle says that, if you can prove that the hypotenuse of both triangles are congruent to each other and one other angle, it doesn't matter which, we've got two angles here, it doesn't matter. If you could prove that this top angle is congruent to this top angle over here, that's enough. And we have this theorem, it's called hypotenuse angle. Now I see somebody looking at it and going, hey, but that's two angles and a side. Isn't that the same thing as angle, angle, side? Yes, absolutely. Okay, you could call it angle, angle, side. But in a right triangle, however, it is called hypotenuse angle. Now, does that mean if you don't say hypotenuse angle, it's going to be wrong? No, of course not. Of course not. We always talk about there's more than one way. But if you've got a right triangle, if they give you and start off with a right triangle, if you can prove the hypotenuse in one angle, you can use hypotenuse angle, save you from having to do that all right triangles or all right angles are congruent. So probably save you one step in going about this theorem. Now, the next one is called hypotenuse leg. So if we have a right triangle, okay, here again, if we have a right triangle, and we can prove that the hypotenuse of each triangle is congruent to each other, and another leg. Does it matter which leg? No, it doesn't. Okay? Now, this is the one that's a little special because, when we look at it, and we've talked about with normal triangles, we don't have that side-side angle theorem, that they don't exist for triangles. Well, right triangles are kind of special, and they're special about everything. We don't have a side-side angle theorem for them. We don't have an angle side-side, but we do have a hypotenuse leg. So, with right triangles, if you can prove the hypotenuse is congruent in one other leg, that is sufficient. So there's your shortcut. The next one is called leg, leg. Well, here again, it's only in a right triangle. And if you can prove that two corresponding legs are congruent to each other, that is enough by the leg, leg theorem. Okay, well, I can see somebody going, hey, but look, that's two sides and an angle in between. Isn't that just side, angle, side? Yes, it's the same thing as side, angle, side. But here again, in a right triangle, you can use what's called leg, leg, save you that one step from having to say that all right angles are congruent to each other. So that's all you're looking at on these. We are simply adding those other ones. So now if we look at our list, what can we proving? We have some shortcuts to proving congruent now. Shortcuts to congruence. We have now side, side, side. We have side, angle, side. We have angle, side, angle. Okay, angle, angle, side. Hypotenuse, leg. Hypotenuse, angle. And we have leg, leg. Okay, so when we look at these, so there we go. You've got 7 now, 7 ways. So make sure you know these. Come into class tomorrow. We will have a quiz when you get here, and have a great evening, and we will see you later.